Hi all, in this video segment we'll be discussing about doubly linked list. A doubly linked list is a type of a linked list. The peculiarity is it is a two-way list because one can move in either direction, that is from left to right or from right to left. And this is accomplished by maintaining two link fields inside one node, that is a next and a previous part. So this is an example. Here we have a doubly linked list. For each node, we can see a previous pointer and a next pointer. The previous pointer points to the previous node and the next pointer points to the next node. And thus we can move from left to right or from right to left. So this is the concept of doubly linked list.
Creation of a node. For creating a node, we can use a structure, struct node. Inside that, we can define the variables int data, struct node star previous star next. So this is the structure of the node. We have a pointer to the previous node, a pointer to the next node, and the data part. The common operations on doubly linked list are creation of a node, insertion of a node, searching for a particular key in the doubly linked list, deletion, traversing, and concatenation. In this video, we'll be discussing about the insertion operation. Insertion can be done at the beginning of the doubly linked list or at the end or at any specified position in the doubly linked list.
First, let us discuss the insertion operation at the beginning of a doubly linked list.
Step 1 start. Step 2 creation of a new node. If the creation was not successful, print as node is not created. And if the node creation was successful, initialize the values inside the node like this. Previous part is equal to null, data part equal to key, and next part is equal to null. Then check whether already a doubly linked list was there or not by checking the condition head equal to null. If this condition was true, then we can understand that there was no doubly linked list. So assign the head to the newly created node. Using this statement, head is equal to new node. In the else case, there will be already a doubly linked list. So we have to add the new node to the beginning of the doubly linked list which already exists. So for that, new node next part is equal to head. Previous of head is changed to new node and head is equal to new node. So this is the algorithm for inserting a new node at the beginning of a doubly linked list. Now let us discuss this algorithm using an example. First step is create a node and return the starting address to a variable new node. So this is the node created. The next step is to give values to the different fields of the new node. The previous field is given value null. The next field is also given value null. And the data part is given the value of the key to be inserted. And in this example, 30. If the doubly linked list does not exist, just assign head is equal to new node. If the doubly linked list already existed, we have to add this new node at the beginning of the doubly linked list, that is at this position. And if you are inserting a new node at this position, you have to change the value of this particular field and this particular field. So the new node next part should point to head, and head previous part should point to new node. And afterwards, we have to assign head is equal to new node. Thus, you can insert new node to the doubly linked list. So this is how insertion of a new node is done at the beginning of a doubly linked list. Next, insert node at the end of a doubly linked list. Start. Create a node and store its starting address to new node. If the node creation was not successful, print the message as node is not created. In the else part, initialize the values of different fields of the new node. Assign previous part as null, data part as key, and next part as null. If the head is equal to null, that means a doubly linked list does not exist. In that case, assign head is equal to new node. In the else part, we have to traverse till the end of the doubly linked list, since we have to insert the new node at the end of the doubly linked list. For that purpose, use a temporary pointer variable ptr is equal to head and traverse the doubly linked list till we reach the last node, while pointer next is not equal to null, pointer is equal to pointer next, end while. So when this particular uh, step, these steps are executed, then the pointer will reach the end of the doubly linked list. Now you can change the value of the next part of the current node, that is the last node, to the new node, and the previous part of new node to the pointer. So this is how you insert a new node at the end of the doubly linked list. Now let us see the example. Create a new node. The different fields of new node. Next step is to check whether head is equal to null. If head is equal to null, then this is the first node to be inserted in the doubly linked list. So simply assign head is equal to new node. If there was a doubly linked list, we have to insert this new node at the end of the doubly linked list, that is at this position. So we'll be using a pointer variable to traverse through the doubly linked list and reach at the last node. So there's a pointer variable which is initialized as head, and using the while loop, we'll traverse through the doubly linked list and reach the last node. At this position, we have to insert the new node, and for that purpose, you have to change this field and this field. So pointer next is equal to new node and new node previous is equal to pointer. By assigning this, we can insert the new node to the end of the doubly linked list.
Next, let us discuss the insertion at a specified position of doubly linked list. This is a doubly linked list. So here position 1 is this, position 2 is this, position 3 and position 4. If you want to insert a new node at position 2, that means the newly created node should be in position 2 after the insertion. So that is how you insert a new node at the specified position of a doubly linked list. Now let's see the algorithm. Step 1, start. If position is less than or equal to 0, we cannot insert. So print the message position must be positive. Else, we can create the new node using the malloc function, and the variable new node points to the newly created node. If the new node is equal to null, then the node creation was not successful. Else, you have to initialize the values of different fields of the new node. Previous is equal to null, data is the new key value, and next is equal to null. If position is equal to 1, this means you have to insert a new node in the beginning of the doubly linked list. In that case, new node next is equal to head. and if head not equal to null, head previous is equal to new node. End if. And then the head should now point to the new node. So these are the statements to insert a new node at the beginning of a doubly linked list. Else case. So now we are going to insert a new node in some other position in the doubly linked list. For that you have to set a variable ptr to head and start a counter count is equal to 1. Now these are the statements used for traversing through the doubly linked list, and we have to reach the position where the insertion should be done. Count is less than position minus 1 and pointer not equal to null. By checking these conditions, you have to traverse through the doubly linked list. Now if pointer is equal to null, then print doubly linked list is out of range. This happens when the user inputs a number which is greater than the number of nodes of the doubly linked list and if insertion is not possible. For example, in a doubly linked list which consists of only 3 nodes, if the user is asking to insert a new node at 6th position, it is not possible. In that case, you can print a message like this. Now else part. If pointer next is equal to null, that is, if the traversal continued and if we reached the end of the doubly linked list, you should insert the new node there. So pointer next is equal to new node and new node previous equals pointer. And this will do the insertion of the new node at the end of the doubly linked list. And else case. These are the statements used for inserting a new node in between the other nodes. The next part of the new node is assigned with pointer next. The pointer's next node's previous value is assigned with new node and pointer's next value is assigned with new node and new node's previous value is pointing to pointer. So by using these statements, you can insert a new node in between two nodes. So let us see an example for doing these. So first case, start. If position is less than or equal to 0, you are printing a message like this. And else part, create a node and store its starting address to new node. So you have created a new node and the node creation was successful. So you can initialize the values like this. The previous value equals null, the data value is key, and the next value is null. If the user had given the position value as 1, it means we have to insert the new node to the beginning of the doubly linked list. So here we have to insert a new node at the beginning. The newly created node should be the first node in the doubly linked list after insertion. So new node next part is assigned with head. And if head was not null, it means there is already a doubly linked list. In that case, head's previous is pointing to the new node. So this is the code for inserting a new node in the beginning of a doubly linked list. And if head was equal to null, it means there was no doubly linked list. So you have to point head to the newly created node. So this is the only node in the doubly linked list after the insertion. Now assume that we have to insert the new node at some other position. So for that you have to count from the first position and we should find the place where the insertion is to be done. For that, set a pointer variable to head and initialize a count variable to 1. Now traverse through the doubly linked list until we reach the position where the insertion is to be done. If pointer is equal to null, this means the value given by the user, that is for position, that value is very large when compared to the number of nodes in the doubly linked list, and you have to print the message as doubly linked list is out of range. Now else part, if pointer next is equal to null, then pointer's next part is equal to new node and new node's previous part is pointing to pointer. So let us look at an example. So if you want to insert a node after the third node, so that is at the fourth position. So the new node previous value should be pointing to pointer and pointer's next part should point to the previous. So this is how the insertion is done. Else part, if you want to insert a new node in between two other nodes, these are the statements used. The new node's next part is assigned with pointer's next part. Pointer's next node's previous part is equal to new node. Pointer next is equal to new node and new node's previous equals pointer. So these are the statements used for inserting a new node in between two other nodes. So let us see this with an example. So here we have to insert 20 and the position where we have to insert is 3. That is 1, 2, 3. At this position we have to insert 20. And for inserting 20, which all fields will be affected? So if we are inserting 20 here, this field is to be changed, this field is to be changed, this is to be changed, and this is to be changed. So by changing these 4 fields, you can insert the node with 20 in between these two nodes. So this is the code for inserting a new node in between other nodes. So here we have the new node and this new node is to be inserted at position is equal to 3. So here we have to insert the new node and for that we have to change 4 fields in total. That is this particular field, this field, this field and this field. By changing these 4 fields you can easily insert the new node here. So first the new node's next part, this should point to here. So new node's next is equal to pointer next. So pointer next is already pointing to this node. So new node next is equal to pointer next. Then pointer next previous, that is this portion is now it is to be pointed to the new node. So pointer's next node's previous part is equal to new node. And next is pointer's next part, that is to be pointed. It should be pointing to new node and new node's previous part to pointer. Now we changed the 4 links and thus the new node is inserted at position 3. So this is how insertion of a new node is done in between other two nodes. In this video segment, we discussed the insertion operation at the beginning, at the end, and at a specified position in the doubly linked list. Thank you.